Distribution shapes. Our objective, identify the shape of a histogram distribution. We'll be talking a lot about distribution shapes in this class. And so we want to get this knowledge so that we can apply it as we move forward with a variety of distributions we're going to work with. Histogram distributions are often described by their shape. They are typically classified as symmetric, which is either uniform or bell-shaped, skewed to the left or skewed to the right. So what does that look like as a picture in the histogram? Here is a uniform distribution that is symmetric. Here is a symmetric distribution that is uniform, okay? It basically graphs as almost a rectangle. Every possibility has the same frequency. We're not going to look at a whole lot of these, but that is one type of symmetric distribution, a uniform distribution. Again, we won't be dealing with a whole lot of these because most data is not uniform like this. Here's the symmetric bell-shaped distribution. Bell-shaped because if you kind of connect the tops of the lines, if you kind of connect the top centers, you kind of get a bell, a curved bell shape out of this. So it's symmetric. If I draw a line down the middle, I have the same left and right. Generally speaking, the right side maps to the left maps to the right, symmetrical, bell-shaped. Okay, skewed left is this one. Most of the data is over here on the right, and then at the tail of this goes to the left. That's your skewed left. Things have been skewed this way, to the left. And here's your skewed right. Your data is in here, and then the data falls, the tail goes off to the right. Notice these are not symmetrical. You can't put a line at the high point and then have it be symmetrical. So you're going to be skewed to the left if your tail goes to the left, and you're skewed to the right if your tail goes to the right. Examples that might assist you with this. Okay, uniform symmetric, again, not popular, but the chances of rolling a 1, 2, 3, 4, 5, or 6 with a die. Well, all the chances are the same, 1 out of 6. So you're going to wind up with a uniform distribution like that one. Bell shape. Bell shapes are very popular. Okay, that's going to be kind of like a normal. We're going to talk about normal distributions, and they're often bell-shaped. The average heights of adult women, for example. You have an average where most women fall, and then off to the left and off to the right, it's similar. You've got some that are a little taller than average, some a little shorter than average. You have fewer that are more taller than average, fewer that are less tall than average, and then fewer still that are much taller than average, and fewer still that are much less taller than average. So you get a bell-shaped curve. Another thing you may be familiar with is SAT scores. Okay, most people are kind of in the middle, and then as you go to higher scores, you get fewer and fewer students, and as you go to lower scores, you get fewer and fewer students, and they tend to match over a line of symmetry. Okay, skewed right. The average annual income of U.S. citizens. Most fall in this range, but there aren't that many that are below that. If most fall at $100,000, let's say, and that's probably pretty high, there are a fair number of people who are below that. Okay, but you do have people that get to the 1 billion level. Jeff Bezos, for example. So you have a lot more possibilities for numbers to the right of the average. So there's an example of skewed right. Not as many possibilities below the average, far more possibilities above the average. Skewed left, age of death from natural causes. Most people are dying at a later age from natural causes, and there aren't too many that get a whole lot older than that. Okay? Okay, excuse me, let me say that again. And there are a fair number of people that are in that area, but there aren't too many ages that are greater than that average. Let's say the average age is 80 when people are dying, or 75. Well, from 75 to 100, when most, that's only 25 years, whereas you have people that are dying between 0 and 75. A lot more possibilities, possible numbers down here, and that results in this skewed left diagram here. So our focus, distribution shapes. Uniform is out there. It's obviously symmetric. Draw a line. You can cross over that. But you'll have bell-shaped symmetric. You'll have skewed right, where the tail goes to the right. And you'll have skewed left, where the tail goes to the left.